Yeah. Found the value of R? Yes. Yeah, what's the value of R? 10.5. Okay. Online students, is the value of R 10.5? Okay, so let's see that. You continue working. I'll also work. Sorry? Yeah, please. Yes. What's the improper fraction for this one? 4,851 by 2. So mostly 4851 should be divisible by 11. Yeah, if you know the test of divisibility for 11, you can use that. So 4851, some of the digits in the odd places, correct? 1 plus 8, 9. Even places 9. The difference is 0. Then this number is divisible by 11. Find the sum of the digits in the odd places and the sum of the digits in the even places. If the difference is 0 or a multiple of 11, if the difference is 0 or a multiple of 11, then the number is divisible by 11. So 4851 is divisible by 11. In the denominator, we have 22. So 11 2s are 22. And this one is 11 4s are 44. 4 remains. 4s are 44. 1 remains 1. 441. All right. So now after this, children, you should not multiply. You must not multiply the numbers in the numerator and the numbers in the denominator. All right. Break down the numbers into their prime factors. 441. If you find the factors of 441, you will find 3 into 3 into 7 into 7. We know this method, right? This 441 and, like all this one, we know this, right? So when you find the prime factors of 441, it's 3 into 3 into 7 into 7. Okay, so R cubed is equal to 441 should be written as 3 into 3 into 7 into 7. And there's already a 3 and 7 in the numerator. All right, divided by 2 into 2 into 2. So now R is equal to, from 3 equal factors, there are 3 3s in the numerator. So 1 3 out, 3 7s, 1 7 out, and 3 2s, 1 2. So R cubed is what you see in the first step. So R is equal to, from 3 equal primes, 1 prime out, right? Yeah, so R is equal to 21 by 2 or 10.5. You can have it as 21 by 2 or 10.5 centimeter. Now find 2 pi r square. CSA of hemisphere is 2 pi r square. Find 2 pi r square. So there r square you can use 21 by 2 itself. 21 by 2 into 21 by 2. Yeah, please tell me the value of 2 pi r square CSA. Is 693. I have the final answer. Yeah, correct. 693. Centimeters squared. If you're finding R, then we have to multiply the numbers in the numerator, multiply the numbers in the denominator. If you're finding R. But when you have the equation for R square or R cubed, don't multiply. Break down the numbers and write them as a product of their prime factors. Yeah, next one. Yeah, this is the next one, children. Online students? Done?
Yes, ma'am.
Okay. Yeah, this is the next question.
Ma'am, I have a doubt, ma'am.
Sure, yes.
Ma'am, why do we have two diameters, ma'am?
Just think of a coconut. If a coconut were in the shape of a perfect sphere, coconut, all right? Just imagine a coconut which is in the shape of a perfect sphere. Then that is an example of a hollow sphere. Because where you have the tender coconut water, right? There it is hollow. Yes or no? There's no material there. It's hollow. There it's hollow. And it's like the wall of that sphere is thicker. So in this case, you will have two radii, one internal radius and one external radius. From the center to the inner wall is internal radius or internal diameter. Diameter you understand. So center to the inner wall is internal radius, and from the center to the outer wall, that brown portion, from the center to the inner wall, that white wall, coconut. Okay, from the center to the white wall, it is the internal radius, and from the center to the brown wall, the outer wall, is the external radius.
Like a ring?
Yeah, a ring, like a ring, yeah. But a ring is plain, while this is solid. Yes, like a ring, correct.
Yes, ma'am. Thank you.
Yeah. No, 9th standard. Deletedலாம் இல்ல. எல்லாமே 9th இருந்தே இருக்குதுலாம். Deleted is only frustum of a cone. Others are there. Okay, we'll do this together. Now, a hollow sphere, as I told you, just imagine a coconut which is in the shape of a perfect sphere. Then that coconut is an example of a hollow sphere, because inside that cavity, a spherical cavity is empty, right? Inside there's a cavity. The spherical cavity inside is empty. And then the wall of the coconut is thick. Inside it's empty and the wall of the coconut is thick. So inside there's a sphere, the wall is thick, and outside there's a bigger sphere. Internally there's a sphere of smaller radius, and externally there's another sphere of larger radius, right? Okay, so now how do you find the volume of the material in the coconut? Volume of the material in the coconut. So you need to imagine like this. Imagine that it were once a solid sphere. It was once a solid sphere, and from that solid sphere, a smaller sphere of the same center, but a smaller radius is removed. That's when you have something like a coconut. It's like as if the coconut earlier, just an imagination to understand the situation. Okay. So it's like as if the coconut were earlier a solid sphere. It was intact, like there was material all over inside. Okay. So then its volume would have been, 4 by 3 pi. I'll use capital R. Okay. Because next we're going to see a small r. So I'll use a capital R. So if the coconut were a solid sphere, then its volume is 4 by 3 pi r cube. Now it's like from inside the sphere with the same center but a smaller radius, a spherical thing is removed. A spherical cavity is made, meaning a smaller sphere is removed from the middle. So what is the volume of the sphere that's removed from the middle? The sphere, right? So 4 by 3 pi small r cube. So since a smaller sphere from the middle is removed, that's empty now. In the coconut, there's that empty portion. A spherical cavity is formed because a smaller sphere is removed from the center. So the volume of the resultant, sphere, that is from the solid sphere, if you remove a smaller sphere from the middle, the volume of the resultant sphere is external volume minus internal volume. External volume, or that is the volume of that full thing, 4 by 3 pi r cube, capital R cube, minus what you remove, 4 by 3 pi small r cube. So this is the formula you'll have to use here. The volume of a hollow sphere is 4 by 3 pi capital R cube minus 4 by 3 pi small r cube. As if it were once a solid sphere of radius r, and from that we make a spherical cavity from the middle. How do we make that cavity? From the middle, we remove a smaller sphere of radius smaller. So now it's empty in the middle. One spherical empty portion is there in the middle, like in the coconut. So the volume of the material in the coconut is 4 by 3 pi capital R cube minus 4 by 3 pi small r cube. And when one thing is converted to another, when one solid is melted, when the material in the solid is melted and recast into another solid, their volumes will be the same, assuming that there is no wastage in the conversion process. See, when it's melted and then converted to another solid, assuming that there's no wastage. Because nothing is mentioned about the wastage in the question here. So assuming there's no wastage, the volume of the first solid is equal to the volume. Okay, the volume of the old solid is equal to the volume of the new solid. What was it originally? Hollow sphere. The volume of the hollow sphere is equal to, what is the new one now? Cone. Is equal to the volume of the cone. So write that equation in words and then just write the formula. Substitute the known values, you'll easily find H. Yeah. What's the answer? Yes, I just tell you. Yeah. Perfect. 1-4. You can just write it like this, no? 4 by 3 pi capital R cube minus small r cube. You can take out 4 by 3 pi common and write it like this. So now on either sides, 3 gets cancelled, pi gets cancelled. So R1 is 4. So 4 into 4 into h is not known. We need to find the height of the cone. Okay, is equal to, there's 4 here and in bracket 4 cubed minus 2 cubed. So again, you can cancel this 4 on either sides. So 4h is equal to 64 minus 8. 4h is equal to 64 minus 56. H is 56 by 4. The height of the cone is 14 centimeters. The height of the cone is 14 centimeters. Yeah. 4 by 3? No, that's a formula, right? 4 by 3 pi capital R cubed minus 4 by 3 pi small r cubed. On taking 4 by 3 pi common, in the bracket we have r cubed minus r cubed. The value of r is 4, no? And the other one is 2. No, what's your question? No, diameters. Diameters. When one solid is converted to another solid, their volumes will be the same, not surface area. Volumes will be the same. So volume of the cone is equal to the volume of the hollow sphere. Below that, you should write the formula. Substitute the values and you have an equation where there's only one unknown h. So on solving, you can find the value of h. I think this clears a doubt, no, that it is a part of the syllabus. See, I'll tell you one thing. Yeah. It's okay. See, it's not a totally new concept or a difficult concept which we are spending time on, right? So it's just about the formula which you have to remember, and yeah. Done, children? Online students finished?
Yes, ma'am. Yes, ma'am.
Yeah. This question also, you find it in the 9th standard textbook as well as the 10th standard textbook. Yeah. So try it and then we'll do it together.
Good evening, ma'am.
Oh, hi, Danya. Good evening.
Ma'am, actually, I went to temple, so it became late. I'm sorry. I will make use of the recording, ma'am.
All right. Yeah. I think we finished answering 2 questions, 8 and 9. Yeah. You can take a screenshot, Danya. We started with this one.
Taken, ma'am.
Yeah.
Taken, ma'am. Thank you.
Very good. Yeah. Embankment is the wall that is built around the mouth of the well. Embankment is a thick wall. Like when the well is dug, the mouth of the, when you dig a well, the mouth of the well is on the floor, right? So for safety reasons, there's always a wall which is built around the mouth of the well. So that wall is called the embankment, protection. The embankment is also cylindrical because the well is cylindrical. If the well is cuboidal, then the wall which is built around the mouth of the well will also be cuboidal. Cuboidal meaning there'll be one inside, so it's a hollow. Yeah, it'll be hollow. The wall is thick. There will be a cuboid. You can see the lining of a cuboid inside and outside. Yeah. The volume in that case will be volume. See, whenever the wall is thick, the volume is always external. The volume of the material used is always external volume minus internal volume. So in that case, if it is cuboidal, then it will be capital LBH minus small LBH. Yeah. Yeah, we can use this picture for better understanding of the information. So this is the ground level, children. This is the ground level. Okay. This is the well. This is the well. All right. Now this is the ground level. So you start building the wall around the mouth of the well. See, this is the ground level. Okay. Now this is the well. 1 second. I'm not sorry. 1 second. This one. This one is the ground level. All right. Now, around the mouth of the well, you can see we've constructed the wall, and the wall will be thick. This wall spreads on the ground. Okay, the well is only here. This only is the well. This is the well. And we build the wall around the mouth of the well. The wall will be thick. All right. Now use this figure to answer the question. The values are different. There's a different figure. So the well of diameter 2 meters. So the radius is 1. This is 1 meter. Values are different, children. Diameter is 2 and 14 meters deep. This one is 14 meters. The well is 14 meters deep. Earth taken out is to height of embankment. The height of the embankment is 40. This is the embankment, the wall. That's 40. That's in centimeters. 2 meters, 1 meter, 14 meters. This is 40 centimeters. We need to take care of the unit. Find the width of the embankment. You can convert meter to centimeter or centimeter to meter. So maybe there are two values in meters. So we'll convert 40 centimeters to meter maybe. Anything is fine. Oh, it's gone. Oh. Just 2 minutes, I'll just check. See, always write the equation in words. If we understand something from the information given, right? Write that in words. Write that equation in words. So the well, the earth which is removed to make the well, that is used to build the wall. That is used to make the embankment. Okay. All the earth that is removed to make the well, that is used to construct the wall. So what's the equation? Volume of the earth in the embankment is equal to the volume of the earth that's dug out to make the well. The volume is the same. What you remove, you use that to make the wall. What you remove to make the well is used to make the wall. So the volume of the earth in the embankment, that wall, is equal to the volume of the earth dug out. Now the embankment is a cylindrical shell. The embankment is a cylindrical shell, meaning it's cylindrical, but it's hollow. It's hollow and the wall is thick. It's cylindrical, it's hollow, and the wall is thick. So how do you imagine this solid? This one is like as if it were once a solid cylinder, and from the middle, you've removed another cylinder. How do you get this? How do you imagine this embankment? The embankment, I'm talking to myself. The embankment is like it were once a solid cylinder. And from that solid cylinder, if you remove a cylinder from the middle, the resultant one is this embankment. So it's the external volume minus internal volume. Pi capital R square h minus pi small r square h. Height is the same. So the formula to find the volume of the earth in the embankment is equal to pi capital R square h minus pi small r square h. So you can take out pi h common, and write r square minus r square in the bracket. Formula is pi r square h minus pi r square h, volume of the embankment. So pi h is common, r square minus r square. This is the formula to find the volume of the earth in the embankment. The well is a cylinder, pi r square h. So pi gets cancelled on both the sides. Height, they are different. So let me use this one as h. Okay, I'll use h1 here. So where's embankment? This one is h1. All right. So we have 2 by 5 into r square minus 1 square is equal to 1 square into height of the well 14. So r square minus 1 is equal to 14 into 5 by 2. So r square minus 1 is equal to 7 5s are 35. R square is equal to 36. R is equal to 6. R is 6. So the thickness of the wall is equal to external radius minus internal radius, which is 6 minus, what was it inside? 1. 1, right? Internal radius is 1, right? Yeah. No, I'll tell you. Yeah, that's equal to 5. It's all in meters, right? Yeah, 5 meters. Yeah, I'll tell you. 5 meters. Yeah. The thickness of the wall, the width of the embankment. The width of the embankment is the thickness of the wall. The width of the embankment, meaning the thickness of the embankment. Width is the thickness of the embankment. The thickness of the wall. All right. So in the previous question, we saw a hollow sphere. Okay, I'll not disturb you. Finish it. Online students, finish working.
Just a minute, ma'am.
Yeah, okay.
Completed.
Yeah. Yeah. So in this question, a well is dug. Working still? Yeah. Okay. So here, a well is dug and the earth which is removed from the well is used to construct the wall, the safety wall or the embankment around the mouth of the well. That's what you see in the picture here. All right. So clearly, the embankment is a hollow cylinder. The embankment is a hollow cylinder, as if it were once a solid cylinder, and from the middle, another cylinder of smaller radius is removed. That's how you can visualize the embankment. So the volume of the earth in the embankment is equal to volume of the bigger cylinder minus the volume of the smaller cylinder. So pi cap plus square h. See, when you have two cylinders of the same height but different radius, two cylinders of the same height but different radius. So the volume of the bigger cylinder will be pi cap plus square h, the same height. The volume of the smaller cylinder that's removed will be pi r square h, same height, different radius. So when you take out pi h common, so this is the formula to find the volume of the earth in the embankment, pi h into cap r square minus small r square. So when you read this question, the equation you can construct in words is the volume of the earth in the embankment is equal to the volume of the earth that's removed from the well. So pi h cap r square minus small r square is equal to, the well is a cylinder, pi r square h. Be careful, differentiate the heights. H, I've called h as the height of the well, h1 as the height of the embankment. And all the values must be in the same unit. So we have 1 meter, 14 meters, and 40 centimeters. So I've converted 40 centimeters to meter. Then you just need to write this equation in words and then substitute with the relevant formulae. Pi gets cancelled on both the sides. Use the values and we find R. Capital R is 6. Okay, so on the top, what do you see? On the top, this is the internal radius. How much? Embankment internal radius 1. This is the external radius, this one. I'll use the next slide, sorry. See. The internal radius is 1 meter. The external radius is 6 meters. So see, 1 plus 5 is 6. From here to here is the external radius, right? This one is 1, but this full thing is 6. So that means the thickness of the wall is 5. This one is 1. Internal radius. This is 1. This is 1. But this whole thing, external radius is 6. So that means the thickness of the wall is 5. Correct? 6 minus 1. Thickness is equal to external radius minus internal radius. 6 minus 1, 5. And children? So here we come across the formula to find the volume of a cylindrical shell. It's very simple to remember. Cylinder is pi r square h. Just use capital R and small r. External volume minus internal volume. Pi capital R square h minus pi small r square h. H is the same, height is the same. Only r is different. Capital R, small r. So when you take out pi h common in the bracket, you have r square minus r square. Capital R square minus small r square. This is the formula to find the volume of a cylindrical shell. Also a hollow cylinder where the wall is thick. And in the earlier question, we saw a hollow sphere where again the wall is thick like in a coconut. Hollow sphere. So nothing difficult about the formula. Sphere we know is 4 by 3 pi r cube. Hollow sphere where there are two radii, it will be 4 by 3 pi capital R cubed minus 4 by 3 pi small r cubed. External volume minus internal volume. 4 by 3 pi capital R cubed minus 4 by 3 pi small r cubed. External volume minus internal volume. So when you take out 4 by 3 pi common, r cubed minus r cubed in the bracket. Let me know if you have. Now this question is similar question is in NCRT, but just let me know if you've worked this in school. Similar question is in NCRT. Not same. Finding the time, like water flows from a source and is getting filled in some other place, like from a canal, it flows into a cylindrical or some shape, conical tank, whatever, or a hemispherical tank. Find the time in which the tank will be filled. Questions like this, no? Yeah, it is a part of the syllabus. No, I'm checking because the earlier some we had a doubt, right? That's why I'm checking. Yeah. Children, only frustum is removed. Only frustum is removed. To be safe, it's, it's good to learn this. You have come across in school? Similar question? Yes. Yeah. How many values in centimeter? This is centimeter. Okay. So looking at the different values, 10 meters, 5 millimeters, 40 centimeters, there are 4 numbers in this question. 2 with unit centimeter, then 1 with meter and the other one with millimeter. So it's your choice to convert to any common unit, is your choice. So I've just taken centimeter everywhere. I've converted meter and millimeter to centimeter. Yeah, I'll explain that. Yes, yes, I will explain that. Yeah. Okay. So the question is, a conical vessel is being filled with the help of a cylindrical pipe. A conical vessel is getting filled with water with the help of a cylindrical pipe. Now, the rate of flow of water from the pipe is given to you 10 meters, that length of water column, 10 meters per minute. I'll finish and then you can ask me questions on flow. Okay. So the rate of flow of water is given to you 10 meters per minute. Given this, and also the parameters for the cone, radius and height of the cone is given to you, you need to find the time taken by the cylindrical pipe to completely fill this conical vessel. That's the question. How long will it take? How long will it take for the pipe to fill the conical vessel? That's the question. Okay. So the equation in words is the volume of the water that flows out from the cylindrical pipe will be equal to the volume. Then you have to shut the tap. You will not, once it's filled, you will have to shut the pipe, right? So the tap. So the volume of the water that flows out from the cylindrical pipe is equal to the volume of the water that's filled in the conical vessel. See, whatever water is discharged from the pipe is filled in the conical vessel. So the volume of the water that comes out of the cylindrical pipe is equal to the volume of the water that's filled in the conical vessel. Yes or no? That's equal. If you write this, that's it. That's all it is. The answer is all about writing this equation in words. The answer is all about writing this equation in words. The volume of the water that flows out of the cylindrical pipe is equal to all the water that flows out from the cylindrical pipe is filled in the conical vessel. So the volume of the water that's discharged from the conical pipe, cylindrical pipe is equal to the volume of the water filled in the conical vessel. That's the equation in words. So always write the equation in words. Write out all the values given. See, here there are 2 things, cylindrical pipe and conical vessel. There are 2 things, cylindrical pipe and conical vessel. Write out the values given radius, height and all that, and differentiate them, because in both we have radius and height. So you can use R1, R2, H1, H2, or capital R, small r, capital H, small h. All that is not going to affect your answer, because you use R1, R2 or H1 or capital H, small h, your answer is not going to be different. So differentiate the values like that, understand? And make sure that all the numericals are in the same unit. That's very important. All in the same unit, any unit, but same unit. So read the question. So we see a cylindrical pipe and a conical vessel. So write out the radius, height of both in the same unit. Keep this ready. Now write the equation in words. Write the equation in words. Volume of water that flows out of the cylindrical pipe. Cylindrical pipe into how long it flows, we don't know, right? Now here it is per minute. What volume you find here will be per minute, because the height, I'll explain, because the height is given per minute, 10 meters per minute, that length of water comes out. Into how many minutes, we don't know. Like this, how many minutes it's going to be let out, we don't know. Into X minutes. The volume which you find now will be the volume of the water that comes out per minute. Why? Because the height is given per minute, 10 minutes. Okay, let me tell you that first thing. See, it's like the height. Now, the cylindrical pipe, what is this 10 meters per minute? That length of water column, comes out of the pipe in 1 minute. 10 meters. It's a cylindrical pipe, right? Say, just imagine it's horizontal, cylindrical pipe. 10 meters. That length of water comes out of the pipe in 1 minute. So when you find the volume using 10 meters as the height, you will get the volume of water that has come out of the pipe in 1 minute. Why? Because the height is given per minute, 10 meters per minute. 10 meters is too long. 1 meter is 100 centimeters. So 10 meters. That length of water column, that length of water is thrown out of the pipe in 1 minute. Radius is there. You can see the radius of the cylindrical pipe. The diameter is given, so you see the radius there. Okay, so that's the opening of the cylindrical pipe, the diameter or the radius there. Now, what is the length of the water that comes out per minute? 10 meters. That much of water comes out in 1 minute. So when you find the volume of the cylinder using the formula pi r square h with these values, 5 millimeter diameter and height 10 meters, you get some volume, right? That's the volume of the water that comes out of the pipe in 1 minute. Why 1 minute? Because 10 meters, that length comes out in 1 minute, right? So when you find the volume using this radius and this height, that's the volume of the water that comes out in 1 minute. Like this, it should be open for 2 minutes, 3 minutes, half a minute, we don't know. So into that, 1 minute, this much water comes out. So for 10 minutes into 10, right? In 1 minute, this volume of water comes out. If you multiply that with 10 minutes, that's the volume of water which comes out in 10 minutes. That's why into X minutes. This is the volume of the water that comes out in 1 minute. Into how long, we don't know. So into the number of minutes is equal to the volume of water filled in the, or it's equal to the volume of the conical vessel. Is equal to the volume of water in the conical vessel. Since we are taking the height as 10 meters and 10 meters is the length of the water that is discharged in 1 minute, the volume which you get is also the volume that has come out in 1 minute. Because height is given. If the height was given per hour, then it is the volume of the water that has come out in 1 hour. If the height of the water column was given in seconds per second, 10 meters per second, then when you find the volume, it will be the volume that has come out per second. All right. So volume of the water that flows out of the cylindrical pipe. This is per minute. This is per minute into the number of minutes is equal to the volume of the. So many minutes it was open. And where is the water now? It's collected in the conical vessel is equal to the volume of the water in the conical vessel. This is the equation in words. Now this one is for cylinder. I've used R and H. So pi R square H into X minutes is equal to 1/3. I've used capital R and H1. 1/3 pi R square H1. That's all. If you write this, you got the answer. Got it? Yeah. Yes or no, children? Now see here. Now converting, you don't go wrong. 5/2 millimeters. Please listen to this. So I have converted everything to centimeters. Not everything. 40 centimeter, 24 centimeter already in centimeters. So the other two values, 10 meters and 5 millimeters. How do you convert meters to centimeter into 100? 1 meter is 100 centimeter. What about millimeter to centimeter? Should divide by 10. So see here, 5/2 divided by 10. And before that, 5 mm is the diameter. 5 mm is the diameter, not radius. So 5/2 is the radius and divide 5/2 is the radius, 5/2 mm. And divide that by 10. Why? To convert millimeter to centimeter. So division becomes multiplication. And 10 becomes 1/10. And on cancelling 5 ones are 5 twos are. So 1/4. You should write these values carefully. Only then all your efforts will, fetch you 4 marks or whatever. Yeah. Yeah, now let's fill the values. What gets cancelled before we start? Pi gets cancelled on both the sides. R 1/4, 1/4 into 1/4 into H 1000 into how many minutes we don't know is equal to 1/3 into 20. 20 into 20 into 24. That's it. All sums based on water, same idea. No difference, same idea. Yeah, children. Yes. 51.2 minutes. 51. Yeah. You can also take a formula for this. So time is equal to volume of the container. Okay, volume of the container. You can modify the formula according to the situation. So in this case, the container is a conical vessel. So volume of the conical vessel divided by volume of the source, meaning the cylindrical pipe or canal or whatever, from wherever whatever is getting filled, So volume of the water, volume of the, I'll just write source, okay? This will be given in unit time. It will be given for 1 second, in 1 second, or it will be given in, this will be given or in 1 minute or 1 hour, all that will be given here. So if this is if this one is given, that height of the water column, if it's given per second, then this time is in seconds. If it's given per minute, 10 meters, if 10 meters, that length of the water is discharged in 1 hour, then the answer which you get here will be in hours. Based on this, you should write the unit for the answer based on this. See, 10 meters per minute. Then your time is in minutes. The answer which you get, no, time is in minutes. If it's given 10 whatever per second, then the answer you get is in seconds. If it's given 10 meters whatever per hour, then the answer is in hours. You can also use this formula. See, this is very vague, what I've written here. So you should modify the formula according to the situation. So here you must write time is equal to volume of the conical vessel divided by volume of the water that flows out of the cylindrical pipe in 1 minute. Okay, let me write the specific one. No, 1 minute. I'm not happy with what I've written. So volume of the container divided by volume of the source. You understand that, right? So in this case, so time is equal to volume of the conical vessel divided by volume of water that flows out of the cylindrical pipe per minute. When you divide this, that's what we're doing here also. You can see that x is equal to, it comes to division only, not to the other side. X is equal to 1 by 3 pi r square h1 by pi r square h it is. It's division only. So I'm not working this children here. Okay, online students, use emoji, raise your hand. Rajit, Tanya, Florentina, Rakshita, Krishnatik, and Krishmi. All actually. Yeah. Thank you. And I'm sure you'd have solved this. What's the value of x?
51.2.
1.20.
Very good.
51.2, ma'am.
Very good. 51.2 minutes. 51.2 minutes. So let's revisit. So there is a container here, a conical vessel. It can be a tank, whatever, and water is being filled using a cylindrical pipe. No, I think you will not listen. No, 1 minute. Very good. We have another question like that. Okay, so first write out the two things in the question, the cylindrical pipe I'm talking about the same thing. The cylindrical pipe and the conical vessel. Please write out the radius height of both and use different letters because in both you have R and H, right? So please use different letters to differentiate the radius and height. And also make sure that all the values are in the same unit. All right. Okay. So that part I think you can manage here. Now what's important is about the cylindrical pipe, the length of the water. The length of the water discharged per minute is 10 meters, which is taken as the height. 10 meters per minute. This 10 meters is taken as the height of the water, the height of the cylinder. Because water flows out through the cylindrical pipe, right? So when water flows out through the cylindrical pipe, the shape of the water is also cylindrical. So how will you find the volume of the water that comes out? By R square H. Water is flowing out through the cylindrical pipe. So how will you find the volume of the water that comes out? Water takes the shape of the container. So it's flowing out of a cylindrical pipe. So water, before it comes out and loses its shape, it is cylindrical. So since it's flowing out of a cylindrical pipe, you can find the volume of the water that is discharged using the formula to find the volume of a cylinder. 10 meters is taken as the height of the water column. Discharged in 1 minute. 10 meters is taken as the height of the cylinder. And the volume which you find is the volume of water that comes out in 1 minute because the height is 10 meters per minute. So first write the equation in words. First write the equation in words. Volume of water that flows out of the cylindrical pipe per minute. Volume of the water that flows out of the cylindrical pipe per minute. And we don't know how long we'll keep it open. So into X minutes. Or into X hours, depending. This is per minute, no? So it will be X minutes. If it is per hour, into X hours. We don't know how long we're going to keep this open. So into X minutes is equal to the volume of the water collected in the conical vessel. If you write this, then it's all about writing the formula, substituting the values and calculating. Yeah. Yes, Shilu. Try this. To do this, we need to recall some conversions. Please tell me what is okay, fill in the blanks. 1 kiloliter is equal to dash meter cubed. And 1 liter. You first finish this one. 1 kiloliter is equal to dash meter cubed. Okay, so 1000 liters. 1 kiloliter means 1000 liters. There's nothing but 1000. 1 kilo means 1000. 1000 liters is equal to 1 meter cubed. 1 meter cubed is equal to 1000 liters. Then what's a connection between centimeter cubed and liters? 1 liter is equal to 1000 centimeter cubed. 1 liter is equal to 1000 centimeter cubed. You need to remember this. I'll explain what it means. You can remember these two. 1 kiloliter means 1000 liters. 1000 liters is 1 meter cubed. And 1 liter is 1000 centimeter cubed. Okay, let's understand this. What is this? Now, imagine are we ready to listen? Now we'll talk about this one first. Imagine a cubical tank. Cubical. All right, tank of edge 1 meters. 1 meter is 100 centimeters. 100 centimeters is like your scale 15 centimeters, so 100 meters. Sorry, 100 centimeters. 1 meter is 100 centimeters. And what is 100 centimeters? Like your scale 15 centimeters, 30, 45. So that length. Huh? Yeah, 4 long ones. Okay, that's it, 30 centimeters. That becomes 120 there. Okay, so that one. So 1 meter. Imagine a cubical tank of edge 1 meter. So edge 1 meter meaning length is 1 meter, breadth is 1 meter, height is 1 meter. Now this tank has a volume of 1 into 1 into 1, 1 meter cubed. The volume of a cubical tank of edge 1 meter is 1 meter cubed, because 1 into length into breadth into height, 1 into 1 into 1 is 1 meter cubed. Now this cubical tank of edge 1 meter can hold 1,000 liters of liquid. It can hold 1,000 liters of liquid. That's the meaning of this conversion. 1 meter cubed is equal to 1,000 liters. Meaning, see, the tank need not be cubical. The tank can be of any shape. I'm just using a cubical tank to explain how we get the volume 1 meter cube. So it can be any tank whose volume is 1 meter cube. It can be cylindrical, whatever shape, conical, whatever shape, or some irregular shape also, but the volume is 1 meter cube. So if a tank has a volume of 1 meter cube, it can hold 1,000 liters of liquid or 1,000 liters of water. So I just took cubical tank so that I can say length 1 meter, breadth 1 meter, height 1 meter. So its volume is 1 meter cube. The volume of the cubical tank is 1 meter cube. Now this tank can hold 1,000 liters of liquid. Now the next one is 1 liter is 1,000 centimeter cube. So now again imagine a cubical vessel of edge 10 centimeters. Cubical vessel. Something like this. Now this is a cylindrical vessel. This is cylindrical. So if this like this, a cubical vessel. Okay. Now a cubical vessel of edge 10 centimeters. Cubical vessel of edge 10 centimeters. So 10 into 10 centimeter into 10 centimeter into 10 centimeter, 1,000 centimeter cube is the volume of that cubical vessel. Now that can hold 1 liter of liquid. That's the meaning. 1,000 centimeter cube is equal to 1 liter, meaning if a cubical vessel has an edge of 10 centimeters, so 10 into 10 into 10 is 1,000. So the volume is 1,000 centimeter cube. Now that vessel can hold 1 liter of liquid. If the volume of a tank is 1 meter cube, it can hold 1,000 liters of liquid. If the volume of a tank is 1,000 centimeter cubed, it can hold 1 liter of liquid. This is the volume of the tank, 1 meter cube, 1,000 centimeter cube, volume of the tank. Then this tank can hold 1,000 liters of liquid. This tank can hold 1 liter of liquid. So remember these conversions. Write down, make a note in your book. Both of these two are the same. 1 kiloliter, 1,000 liters, both are the same. Let me just write it again. 1,000 liters is equal to 1 meter cube. 1,000 centimeter cubed is equal to 1 liter. Yeah. What's that you got? Volume. Then calculate. Find the volume of the hemispherical tank, children. You can even convert it to see if you see to make it easier, you can convert this to centimeter also. You can get rid of the decimal point for that reason. You can convert this radius to centimeter. You can get rid of the decimal point. So you can do that also. Is equal to 1.75 into 100. 1 meter is 100 centimeters. So this is 175. 1 minute. Let me just write it again. Sorry. Hemispherical tank. Radius is 1.75 meters. To get rid of the decimal point, you can convert that to centimeters into 100 centimeters. So that is 175. So volume of water in the hemispherical tank. Seven fives are 35. So I'm using the calculator, children. 4 into 20. See, in the exam, see, now we've been working sums from volumes and surface area. So we've been, like doing multiple. In the exam, it will be a mixture of questions, right? Not everywhere you will have such huge calculations. Wherever chapters 10 questions are, so you will do it easily. Now we've been working on sums only from this chapters. We've been calculating, multiplying, dividing. So it's like hectic. Yeah, so you can use proportions to convert children. Let me finish it and then explain. I'll just. You can write it directly also if you don't want to use a proportion. You don't know, right? Product of means is equal to product of extremes. Product of means is equal to product of extremes. Sorry? Louder? Yeah. Yes, that's all it is. Just division. All right. So in this question, there's a hemispherical tank. Okay. And it's completely filled with water. You need to find, there's an emptying pipe. It's connected. So at the base of the tank, probably there's an emptying pipe. Now the emptying pipe can empty the tank at the rate of 7 liters per minute. Okay, the tank has to be probably cleansed. So they're emptying the water from the tank. Hemispherical tank full of water. An emptying pipe empties the water in the tank at the rate of 7 liters per second. So if you keep the emptying pipe open, in 1 second, 7 liters of water is discharged, comes out. The question is, if this hemispherical tank is full of water, how long will the emptying pipe take to empty all the water in the tank? That's all it is. Hemispherical tank full of water. The water has to be removed from the tank. So there's an emptying pipe. The emptying pipe, when kept open, removes 7 liters of water in 1 second. 1 second, 7 liters of water comes out. Now the question is, how long will this pipe take to empty the tank? First, find the volume. I converted R to centimeter just to get rid of the decimal point, nothing else. You don't have to convert also. 175 centimeters radius. Now volume of water in the hemispherical tank, 2 by 3 pi r cubed, and you can see that fraction there. Now it's given as 7 liters per second, right? 7 liters per second. So convert that liters to centimeter cubed. 1 liter is 1000 centimeter cubed. So 7 liters will be 7000 centimeter cubed, right? If 7 liters is emptied per second, how many centimeter cube? Because we have volume in centimeter cube. Volume is for the hemispherical tank, we have found the volume in centimeter cube. But for the emptying pipe, the volume is given in liters. Both volume only. The emptying pipe volume is 7 liters per second. Hemispherical tank volume is in centimeter cube. Have both the volumes in the same unit. You can even convert this one to liters. You can convert this one also to liters. I'll do it that way also. You can also convert this one to liters. Have both the volumes in the same unit, either both in centimeter cubed or both in liters. So I have converted 7 liters per second to centimeter cube. Liter and centimeter cubed both are units of volume. Liter is unit for volume. Centimeter cubed is also unit for volume. Have both the volumes. So there are two volumes here. What? One is 7 liters, which is the volume of the water emptied in 1 second. The other volume is the volume of the hemispherical tank. Now that emptying pipe volume is in liters. Hemispherical tank volume is in centimeter cube. Please convert, have both in the same unit, that's all. So here I'm converting that liters to centimeter cube. 1 liter, 1000 centimeter cube. 2 liters, 2000 centimeter cube. So 7 liters is 7000 centimeter cube. Let me talk about this proportion later. Okay, so you understand this. So 7 liters comes out in 1 second means 7000 centimeter cube comes out in 1 second. 7 liters of water comes out in 1 second means 7000 centimeter cube. That volume of water comes out in 1 second. That conversion is what I've done here. So sometimes in the exam, we might get confused as to, should I multiply, should I divide? So use a proportion. It works very quickly. This is the general rule. 1 liter is 1000 centimeter cube. That's a general rule. 1 liter is to 1000 centimeter cube is as to 7 liters means how many centimeter cube? Liter, centimeter cube, liter, centimeter cube. Write the order correctly. If you write liter, centimeter cube here, you should write liter, centimeter cube. Same order on both the sides. See, don't neglect this, children. This is very useful to convert. 1 liter is 1000 centimeter cube. 7 liters is how many centimeter cube? You understand that? How do I read this? 1 liter is to 1000 centimeter cube is as to, this is to. This one is as to. Is as to 7 liters is to x centimeter cube. So product of extremes is equal to product of means, right? So x into 1 is equal to 7 into 1000. So x is equal to 7000 centimeter cube. You can do this quickly in the rough column. You don't have to show this as a part of the main working. But good, you showed it's good. Now we converted. All right, 7 liters. So what have we done? We've just converted 7 liters to centimeter cube. That's all. Yeah. Now we understand 7000 centimeter cube of water is coming out in 1 second. Then this much centimeter cube of water will come out in how many seconds? 7000 centimeter cube of water comes out in 1 second because 7 liters means 7000 centimeter cube. That volume comes out in 1 second. Now for us, this volume has to come out. That will come out in how many seconds? So that also I'm using a proportion. 7000 centimeter cube comes out in 1 second. Then this volume will come out in how many seconds? So again, product of extremes is equal to product of means. 7000 into y is equal to 33687500 by 3 into 1. So y is equal to 33687500 by 3 into 7000. 2 zeros, 2 zeros. Please cancel, children. The answer will be in seconds. What's answer, children? Yeah, just. Yeah. So because it's too large for seconds, you can convert it to minutes. Now you're going to get furious with me. Divide by 60 to convert it to minutes. Yeah. No. You should not divide that decimal. That go back to the go back to that fraction. Because இல்லனா அந்த sorry அந்த டெசிமல் வரதுக்கு முன்னாடி ஒரு ஃபிராக்ஷன் இருந்திருக்கும்ல அதை எடுத்து டிவைட் பண்ணுவோம் 60ஆல. ஏன்னா அந்த இம்பர்ஃபெக்ட் டெசிமல்ல மறுபடியும் டிவைட் பண்ணக்கூடாது. So about 26.7 minutes approximately. Not getting this? No. Calculator, you should get it. Meaning the same fractions you have, right? Louder. Louder. No, divide by 60 to convert it to minutes. Yeah, correct. The calculations might make us feel that it's difficult, but it isn't. So you just need to read the question, 2-3 times to understand the information given. It's very practical. So there is a hemispherical tank, radius is given, so you can find the volume of the water in the tank. All this water has to be emptied. So there's an emptying pipe and they've given you the speed of the water that flows out of the emptying pipe, 7 liters per second. Remember that. Okay, now for the tank, the hemispherical tank, the radius is given in meter and we converted that to centimeter because we wanted to shift the decimal point, or you can have it in meter itself. All right, if you have it in meter, you'll get the volume in meter cube. Centimeter, you'll get the volume in centimeter cube. Okay, so here we have it in centimeter cube. The emptying pipe volume is given in liters. Convert that also to centimeter cube. You should have both the volumes in the same unit. Should have both the, or you can also convert the centimeter cube to liters. Let's do that. You can also convert the centimeter cube to liters. So how much? Three 7500 by 3. 33687500 by 3 centimeter cube. So how do you convert centimeter cube to liters? 1 liter is 1000 centimeter cube. So you should divide this by 1000 to find liters, right? You should divide this by 1000. So this is nothing but, I'm just doing it roughly, 33687500 by 3 into 1000. You should divide by 1000. So you will get, is this divisible by 3? 7, 12, 20, no? Okay, so zeros and zeros gets cancelled. And 3, no, this is in 5 tables. So 5, 6 are 30. 3 remains, 5, 7 are 35, 5, 3 are 15, 3, 5, 7 are. Correct? Yeah. And this one is 2. 67375 by 6 liters. You should have the volumes in the same unit. So centimeter cube per liter kuda matramli. We found the volume of the hemispherical tank in centimeter cube, right? You can convert that to liters. How? 1 liter is 1000 centimeter cube. So This centimeter cubed is how many liters? You should divide by 1000. Now it's easy. See, 7 liters comes out in 1 second. 67375 by 6 liters will come out in how many seconds? 7 liters per second. So that's all. See, the thing is you have both the volumes in the same unit. If you don't want to convert 7 liters to centimeter cube, you can convert the tank's volume to liter. So 7 liters comes out in 1 second. This liters will come out in how many seconds? So you can use the proportion also. If you don't know if you have to multiply or divide, you can use a proportion. 7 liters in 1 second. 67375 by 6 liters in how many seconds? Y seconds. So product of extremes is equal to product of means. Work that and find the value of y, you'll get the same thing. Children online, any questions? Florentina, Danya, Rakshita, Rajit, Krish.
No doubts.
Ma'am.
No doubts, ma'am.
Just check if you remember. We worked this in the past. Let's just switch the chapter, children. I think you must be tired with the calculation. So I'm not going ahead with volumes and surface areas. Let's recall from the past. See if you can work this. Try question number 7. This is quadratic equations, standard questions. Please do the 7th one. Take down the 7th question. Try the 7th one. Just take you to that slide. 1 second. Yes, this one. Yeah. Somebody online tell me what is the condition for equal roots, children?
B minus
B
4AC.
square minus 4AC is equal to 0.
B square minus 4AC is equal to 0. D is equal to 0. Correct? Very good. So you'll have to work with that condition because it's given that this quadratic equation has equal roots. That means D is equal to 0. Yeah, somebody online help me, no? We'll do together. Okay, let me wait for some more time. Maybe you want to finish it. You already started. You want to finish it.
Completed, ma'am.
Very good. Yes. Yeah, Daniel. Tell me.
Here we have to first segregate A, B, C, ma'am.
Very
A
good.
is
Yeah.
1 plus M square, B is 2MC, and C is C square minus A square.
Correct. Okay. So these are the expressions for A, B, and C. On comparing the given quadratic equation with the standard form, ax squared plus bx plus c is equal to 0. Compare the given quadratic equation with the standard form. I'm using capital A, B, C because we already have A and C in the equation. So let's use capital A, B, C. So ax squared. So what is a? X squared cancel. So a is 1 plus m squared. You can see here 1 plus m squared. Cancel this x and x. So b is 2mc. And then c, don't cancel the c and the c. This is capital C. So this one is c square minus a square. So on comparing the given quadratic equation with the standard form, you're able to get the expressions for a, b, and c, the coefficients a, b, and c. Yes, Tanya.
By using the condition D is equal to 0, ma'am, that is B square minus 4AC is equal to 0. Substituting the values, ma'am, B square is 2MC the whole square minus 4 into 1 plus M square into C square minus A square is equal to 0, ma'am.
Okay.
Then 4M square C square minus 4 whole bracket C square minus A square plus M square C square minus A square M square is equal to 0. Then multiplying minus 4 with inside.
Make it simpler.
Let's cancel 4. Ma'am.
Cancel this 4 and this 4. Huh?
Yes, ma'am.
Go common, or you can divide by 4 throughout. Divide every term by 4. Divide every term by 4. You can take out 4 common. That's right. Divide every term by 4. 4m square c square divided by 4 minus 4 c square minus a square plus c square m square minus a square m square by 4. Dividing every term in the LHS and RHS by 4 to make it simpler is equal to 0 by 4. So 4 and 4 cancels. 4 cancel. 0 by 4 is 0. So we have m square c square minus. Now, yes, Tanya, please continue like this.
minus c square plus a square minus c square m square plus a square m square. M square c square and c square m square get cancelled, ma'am.
Very good. Yeah, continue.
We now the minus c square gets transposed to the RHS and it becomes plus c square. Here a square minus c square a square m square is remaining, and taking a common we have 1
A
plus
square
m
common.
square.
Very
A square
good.
common, we, yeah, 1 plus m square is equal to c square.
Very good. So c square is equal to hence proved. So again, if you look at this one, children, it's just using the condition d is equal to 0 is given to us. The given quadratic equation has equal roots. So d is equal to 0 is given to us. That means b square minus 4ac is 0. And ABC expressions you can compare and get it from the given quadratic equation. Substitute, and then to make it simpler, divide the LHS and RHS by 4. Every term in the LHS and RHS by 4. And then you can see m square, c square, m square, both are the same. So they get cancelled, plus minus, they get cancelled. And keep looking, keep a watch of the final result. What is that final thing you need to get? You need to get this one. So accordingly, proceed. We have only 3 terms, minus c square plus a square plus a square m square. We have only 3 terms. Yeah, I'll just wait for some time. You need to complete it, please work it. So Rakshita has shared her answer. Okay. Very good, Rakshita. So you can also take out 4 meaning remove 4 by dividing by 4 throughout. But it's still good.
Okay, ma'am.
So let's read the question. If the equation 1 plus m square of x square. So the 1 plus m square is a coefficient of x square. 1 plus m square is the coefficient of x square. Because quadratic equation, we have x square term, x term and constant, right? Quadratic equation, we have x square term, x term and constant, or maybe y square term, y and constant. So here 1 plus m square of x square. So the coefficient of x square is 1 plus m square, which is a. Then plus 2mcx, x term. So 2 plus 2mc is the coefficient of x. And the constant is the entire thing, plus c square minus a square, plus of c square minus a square, or simply c square minus a square is a constant, c. So we have a, b, c. Now what is given? The quadratic equation has equal roots. It has equal roots. That means d is 0, which means b square minus 4ac is 0. And we have ABC from the quadratic equation. So substitute, put those values and work that. And you see that there are 3 terms, like you have 2 terms in the LHS and 0 in the RHS. After substituting, we have this one and this one in the LHS and 0 in the RHS. And you can see that 4 is here, 4 is here. And you can always divide 0 by 4. So divide by 4 throughout to simplify the equation. And then just like that, you get it. See, they get cancelled. You have only 3 terms remaining. Look at the final result. You need to get c square is equal to something. So take c square alone on one side. You need to get this result. C square is alone. So take that alone on one side. Have the remaining terms on the other side. A square common and you get it. Yeah, do this one. Do this one, children. No. Keeping the time in mind, 1 second. Do this one. Here also, Raja, what's given? Roots are equal, right? So what's the condition? T is equal to 0. That means b square minus 4ac is equal to 0. What's the value of, what's the expression for b? Louder, huh? With the sign. See, this is ax square plus bx plus c is equal to 0. Cancel this x and x. Whatever remains is b. So I'll just tell you again. See here. Just write ax square plus bx plus c is equal to 0. All right. Cancel this x square and x square. That is a. X and x. The remaining is b. Now tell me. B square minus 4ac is equal to 0. So what is b, Raja? Yeah. This one whole square. So that means, see, from here you should put the square. From here you should put the square, right? Minus 4 into a. What is a? Into c. Yeah, quickly tell me the value of this one. What is minus 2 square? 4. Then this will be AC plus BD whole square. Minus, let's just write all this. Or you can multiply. So what do you get? A square C square. Then plus A square D square plus B square C square plus B square D square is equal to 0. Now use the idea we used in the last one. What should you do next? To simplify the equation? Yeah, divide by 4. Divide the first term by 4, the second term also by 4, and this one also by 4. So what do you get? Expand this one now. Cancel and expand also. Also expand this. What do you get? Sorry? AC square இல்ல. AC square இல்ல. திருப்பி சொல்லுங்க. Oh, you know it. Okay, 1 minute. 1 minute. What is this? Huh? What is it? What is AC into AC? AC square. See, AC into AC la C மட்டும் ஸ்கொயர்ன்ற ஏன் தானே ரெண்டு தாட்டி வந்திருக்கு? Now tell me. Tell me. This one you should square. This one you should square. And then 2 into A into B. So when you square this, what will you get? Why? அதுதான் கேக்குறேன். What is AC the whole square? Na AC into AC தானே. Okay, what is A into A? Then what is C into C? Yeah, A square C square. Then plus B square D square. 2 into AC into BD is what? 2 ABCD ன்னு எழுதிடலாமா? அப்புறம் இந்த 4 கேன்சல் ஆயிடுது. மைனஸ் மல்டிப்ளை பண்ண உள்ள. Yeah. Minus A square D square minus B square C square minus B square D square is equal to 0 by 4 is 0. Then cancel out the, yeah, plus minus. Then plus minus, plus and minus. So what is remaining? Yeah, correct. Now, you know, when we have perfect squares like A square plus 2AB plus B square or A square minus 2AB plus B square, the square terms are always positive. It's either plus 2AB or minus 2AB. So here, these are the square terms. They're negative, so make them positive. So you can change the signs throughout. See, this is the middle term. See, there are 3 terms remaining. 1, 2 and 3 terms remaining. These are perfect squares. A square, D square, B square, C square. They're like perfect squares, right? This is like the middle term, 2 ABCD. The perfect squares, they have to be positive because it's always A square plus B square plus 2AB or minus 2AB, but it's always A square plus B square, positive. Change the signs throughout. So what do you get? Minus A square D square will become plus A square D square. Then plus 2ABCD will become minus 2ABCD. Minus B square C square will become plus B square C square is equal to 0s plus minus both. Changing the signs throughout. You should do that in the LHS and the RHS. Change the signs throughout. Every term, write the opposite sign because the square terms are negative. Or you can take all the terms to the other side. They'll become positive. It's the same. Taking all the terms to the other side, you will get the same thing. Okay. Now, what is this? This is nothing but AD the whole square, BC the whole square, minus 2 into AD into BC is equal to 0, correct? A square D square is AD the whole square, B square C square is BC the whole square, and the middle term 2 into AD into BC is 2 ABCD. So it's a perfect square, right? So you can, this is like x square minus 2xy plus y square. Now quickly tell me, what is this? It's equal to AD minus BC, the whole square is equal to 0. Okay, so that means AD minus BC, the whole square is 0 means AD minus BC is also 0. So that means AD is equal to BC. AD is equal to BC. Let me just work it here. AD is equal to BC. But what answer should you get? You must get A by B, C by D. You must get A by B is equal to C by D. So bring this B here. So you get AD by B is equal to C. Because they want A by B, you want the result like this. So bring the B down is equal to C. Now they want the D there. So A by B is equal to C. The D take it to the other side. So A by B is equal to C by D. This one is not clear. First bring the B here. So you get A by B. Then take the D to the other side. So C by D. So A by B is equal to C by D. All right. Okay, I'll just share this. It's better you take a screenshot, children. Completed? All of you here? Yeah, just share the image with them. Online students, if you have not completed, please take a screenshot. I'll share the image with you, Raju. Done, children? All right, children. So that's it for today's session. Thank you so much. Online students can leave the call. Thank you.
Thank you, ma'am.
Thank you. Good night.
Thank you, ma'am.
Thank you. Good night.